Hi guys, welcome to Trigonometry Day 4. Today we're going to be focusing on finding missing angles. Last class we focused on finding missing sides. Super similar what we're doing today, but now it's just focusing on the angles instead. So in order to do that, it's going to be important that we have an understanding of inverse operations. On the screen here, you'll already see a couple operations and their inverse. Addition and subtraction are each other's inverse. Multiplication and division are each other's inverse. Then we introduced the inverse operation of x squared at the beginning of virtual learning. How do you undo squaring something or something being raised to the second power? What's its inverse operation? Its inverse operation is taking the square root. All right, so now that we've introduced you to those, we're going to go and talk about the new ones that we have with trigonometry now. So we have three new functions with trigonometry. They are sine, cosine, and tangent. And each of those are an operation. They're some operation that, given an input of a number, outputs a different number. And each of their inverse is very simple. It can only really be done on a calculator for our purposes. And that is taking the inverse of sine. So it doesn't have any special name. It's literally the sine's inverse is called inverse of sine. Cosine's inverse is called inverse of cosine. And tangent's inverse is called inverse of tangent. And the only way we're indicating the difference between sine and the inverse of sine is through that power of -1. And you'll notice that that comes up in each of these. That power of -1 is the representation that makes it the difference between the function itself and its inverse. Now let's just look on our scientific calculator at where we find those buttons. So if you go from your main tab, there's these three tabs of different keyboards. So the main one is where you have all the basic functions, and then we have the keyboard, and then we have the function keyboard. And you'll see at the top on the left, it says sine, cosine, and tangent. Those are the basic functions. And right beneath each of them is its inverse sine, inverse cosine, inverse tangent. So those buttons right there are what we're going to be using today in class. So go over and check and see if you can identify where those are. Alrighty. So now let's get started. Similar to what we did last class, I'm going to keep these at the top of the screen for most of class. We have our basic sine, cosine, and tangent functions. Sine of an angle is equal to the opposite side divided by the hypotenuse. Cosine of an angle is equal to the adjacent side divided by the hypotenuse. Tangent is equal to the opposite side divided by the adjacent side. Hopefully you have created some kind of mnemonic device that is sticking with you, helping you remember this. But for most of these problems, I'll keep them up there. Similar to last class as well, we are going to do a lot of practice problems today. I'm going to start by just showing you how to do them, and then slowly you'll take over and do them yourself. We'll also do a couple word problems at the end, but we'll wait till we get there to even talk about that. All right, so here we have a problem. We have three pieces of information being given to us. We have a side that has length of 17, a side that has a length of 8, and an angle with an unknown measurement. So what we have to go and do is first figure out what type of side each of those sides are. So if this is our angle right here, 8 is what type of side, and 17 is what type of side? 8 is going to be our adjacent side, and 17 is going to be our hypotenuse. So then we look at each of the trigonometry functions and ask ourselves which trig function uses hypotenuse and adjacent. So that is going to be our cosine. So what we're going to do now, similar to what we did last time, is just go in and plug in each of these values into that equation. So we have cosine of our angle, which is currently being represented by a question mark, equals our adjacent side, which is 8, over our hypotenuse, which is 17. Now the trick here is that we have to get question mark all by itself. That's what we want to isolate in this situation. So in order to do that, we have to get rid of this cosine. So we need to use the inverse operation to get rid of it. And the inverse operation of cosine is the inverse of cosine. Cosine to the power of -1 gets rid of cosine on this side entirely, leaving us with just question mark equals. And remember, whatever you do to one side of an equation, you have to do to the other. So we also have to take the inverse cosine of this other side. So we now know that the question mark's value is the answer to what is the inverse cosine of 8/17. So what we're going to do now is we're going to jump over to Desmos and do that calculation. We're going to figure out what is the inverse cosine of 8/17. So we'll jump over to Desmos. We go from that main tab to that function tab. We type the inverse cosine. Then we have to go back to the main tab to type in 8/17, which is just 8 divided by 17. And then we got our answer right there. It's 61.9275 and so on. Today we're going to be rounding to the nearest tenth. So it's going to just be 61.9. Since question mark is representing an angle, it's going to be 61.9 degrees. All right, I'm going to do another one just like that, walk you through step by step to hopefully make it a little easier to understand. Okay, so once again, we have 3 pieces of information, an unknown angle and 2 sides. We're going to have to look at these sides and figure out what type of sides they are. 34 is opposite the angle, so that's our opposite side. 39 is attached to the angle and not the hypotenuse, so this is our adjacent side. So the trig function that uses the opposite side and the adjacent side is tangent, so that's the function we're going to use. We're now going to go and plug in each of the values into the equation. Tangent of question mark equals the opposite side's value of 34 over the adjacent side's value of 39. Now, in order to isolate question mark, which is on this side of the equation, we need to get rid of tangent. The only operation that inverses tangent and gets rid of it, undoes it, is the inverse of tangent. So we take inverse of tangent on this side to get rid of tangent and leave us just with question mark. And whatever you do to one side, you have to do the other. So this side will also take the inverse tangent of that number, making the problem become inverse tangent of 34/39. And that's just a calculation we have to do on Desmos. So the inverse tangent of 34/39. Go to your function tab, inverse tangent, go back to your main tab, 34 divided by 39. And that gives you 41.081 and so on, rounded to the nearest tenth. That's 41.1 degrees. Question mark equals 41.1 degrees. All right, so now we've done 2 of these problems. And now I'm going to kind of ask you some more guiding questions to help you get more familiar with the process. First question I want you to answer is, what type of side is 26? What type of side is 45? Go there first. Once you've determined what type of side each of them are, what function should we be using, sine, cosine, or tangent? All right, so let's see if we got that right. 26 is our adjacent side, and 45 is our hypotenuse, making it cosine as the function we should be using. My next question for you is, what is the equation going to look like that when you plug in all of the values, what is it going to become? So it's going to become cosine of question mark equals the adjacent side of 26 divided by the hypotenuse of 45. Great. Now that we have this set up and we want to isolate question mark, what do we have to do to both sides to get question mark all by itself? What we need to do to both sides to get question mark by itself is to take the inverse of cosine of both sides. By doing this, the inverse cosine and cosine cancel each other out, leaving us with just question mark. And the other side of the equation stays as it was from up there, the inverse of cosine of 26 over 45. So now go ahead over to desmos.com/scientific and try to find the answer to that question rounded to the nearest tenth. Remember, you need to be using the inverse of cosine, not cosine. All right, so we're doing the inverse cosine of 26/45. We go to our function tab to find the inverse of cosine, go back to our main tab to do 26 over 45. And that's 54.70 and so on, which rounded to the nearest tenth is 54.7 degrees. Let's try one just like that. All right. What type of side is 34? What type of side is 55? Which trig function should you be using to solve this problem? Now type out what you think the function is going to be. Let's see if we got that right. All right, so 34 is opposite the angle. This is our opposite side. 55 is opposite the right angle, making it the hypotenuse. The equation we should have been using is our sine function because that's what uses the opposite side and the hypotenuse. When we plug in all of the values into the equation, it becomes sine of question mark equals 34 over 55. Now, let's get solving. How are we going to isolate question mark, get question mark all by itself? We're going to take the inverse sine of both sides, because that will cancel out the value of sine, leaving us with just question mark. And then this side is just the inverse sine of 34/55. Okay, now go over to Desmos and calculate the inverse sine of 34/55 rounded to the nearest tenth. Clear all. Function inverse sine back to main 34/55. And that gives us 38.1834 so on, which rounded to the nearest tenth is 38.2 degrees. Question mark equals 38.2 degrees. Don't forget that degrees, it is important. We're dealing with an angle, and degrees how we know if it's an angle or a side. All right. 2 more of these kinds of problems, but I'm going to ask you all of those same leading questions I asked you last time, but I'm not going to stop and tell you my answers in the middle, so let's see how this goes. First question to ask yourself, what type of sides is 29 and 38? What trig function should you use that utilizes those sides? Utilizing that trig function, write it out and put each of the pieces of the puzzle into that equation. We are solving for question mark, so what do you have to do to get the value of question mark? If you haven't been writing the problem down, if you don't have it on a piece of paper, go back, get a piece of paper, write it down so you can answer that question. All right, now go and take that calculation you need to do, go to Desmos and do the calculation. What do you get as your final answer? Okay, let's see how you did. So, 29 is your opposite side. 38 is your adjacent side, making it tangent that you should have been using. The equation you should have written out was the tangent of question mark equals 29, the opposite side, over 38, the adjacent side. It's very important you're doing these in the correct order. It's opposite over adjacent. Now, to isolate question mark, you have to take the inverse of tangent from both sides. That totally isolates question mark, giving us inverse of tangent of 29/38. We're going to go over to Desmos and do that calculation, the inverse tangent of 29/38. When you do that, you get 37.349, which rounded to the nearest tenth is 37.3 degrees. Alrighty, last one like this. I'm going to take away that top bar. What is the value of question mark? Try to bring all of the pieces of the puzzle we just did. If you need to go back and rewatch it, go back and rewatch it to remind yourself, what is the value of question mark? All right, so first thing we have to do is identify what type of sides they are. We have over here an opposite side. We have over here an adjacent side, making it once again tangent, because tangent is opposite over adjacent. We have to rewrite the equation. Tangent of question mark equals 34 over 42. To isolate question mark, we need to take the inverse of tangent from both sides. That leaves us with just question mark on this side. And this side we have tangent inverse 34 over 42. We have to go to Desmos now to do that. Inverse tangent of 34 over 42. When you do that, you get 38.99 and so on, which rounded to the nearest tenth is actually 39 degrees, 39.0 degrees. If that went well, awesome. If not, maybe it's worth watching a couple parts of this video again just to see how we got through step by step of this process. Alrighty. Moving forward, I said we would be doing a little bit of word problems today, so I'm going to tell you some really important words when it comes to trigonometry in general. One of the words is the angle of elevation, and what the angle of elevation is how much you go up to get something. So from this person's eyesight, how far is it? What's the angle at which he has to look up to see the plane? That would be the angle of elevation. Something that is above, that the angle you have to look up, or something needs to be increased to connect, that's an angle of elevation. And then when you have this man trying to see the dog that's smaller than him, that would be called the angle of depression, where he has to look down. It's interesting to note, though, if we're talking about the dog, that's his horizontal line. The dog also has an angle of elevation to see the man. So it's really important that you know what the question is asking like from where to where, because if it's talking about man to dog, that would be an angle of depression. Whereas if it's talking about dog to man, that's an angle of elevation. So that's why we're going to look at some of these word problems. And some of them are going to be just pretty specific about which one you want to use. Just kind of want to introduce those two pieces of vocabulary. I'm not going to make you do these on your own. I'm just going to talk you through how I would solve these just so you can see, be exposed to it a little. We will be doing some of these types of problems for our Kahoot, so I wanted to just expose you to them before we get there. So let's read this problem. It says, a 20-foot ladder leans against a wall so that the base of the ladder is 8 feet from the base of the building. What is the ladder's angle of elevation? All right, so there's two things that I know are part of this drawing. There is a building. That's my building. That's the doorknob. And there is a ladder against the building. So this is going to be my ladder. The other thing we know about this picture is that the ladder is 20 feet tall, 20 feet long. And we know that the base of the ladder is 8 feet from the base of the building. Okay? So we have created this right triangle, and it's asking what is the ladder's angle of elevation? So at what angle is this elevated? So let me show you where that angle is specifically. The angle in question is this angle right here. That's how much it has been elevated from the ground up to the wall. It has been elevated, and it's asking what angle is that being pitched at. And in order to answer that, we have to now figure out what type of side is the ladder, what type of side is the ground. Well, the ladder is going to be the hypotenuse. The ground is going to be the adjacent side. So in this situation, we would be using cosine to solve. We would say the cosine of our unknown angle is equal to our adjacent side of 8 over our hypotenuse of 20. And then we're going to go and solve this problem like we would any of the other problems. What would you do to isolate question mark? We would take the inverse of cosine of both sides. By doing that, we're left with just question mark on the left, which is the goal. And to find that value, we have to take the inverse cosine of 8/20. We'll have to hop over to Desmos to do that calculation. Inverse cosine of 8/20. And when you get that, you get 66.42 and so on. We're going to round to the nearest tenth, 66.4. So now we know that this is 66.4 degrees. So that is our angle of elevation right here. This angle is 66.4 degrees. That's how much the ladder has been raised. Okay, one more word problem. Like that. So it says, question 2, it says a 50-meter vertical tower is braced with a cable secured at the top of the tower. Is a 30, so let me rephrase that. A 50-meter vertical tower is braced with a cable secured at the top of the tower and tied 30 meters from the base. What is the angle of depression from the top of the tower to the point on the ground where the cable is tied? So we have a cable that's 30 meters long and a vertical tower that's 50 meters tall. So here's my drawing of my tower. It's 50 meters long and it has a cable tied to the top. Here's where it's going to be tied to the ground, and that cable is 30 meters from the base. Now it's asking about the angle of depression. Now this is an interesting question because it's not about, think about when it was like the person looking down at the dog. The angle of depression is actually talking about the angle here from the top down, this is our angle of depression. And that might be a little confusing because I'm sure a lot of you thought it was this angle over there. But it's, imagine drawing a horizontal line to create this kind of imaginary right triangle in space. And this is the angle that we want to figure out. That's the angle of depression from the top to where it has been tied. So let's figure that out. If this base is 30, this is also going to be 30. If the height of it was 50, this length is also going to be 50. And then we have to figure out what type of sides they each are. 30 is going to be our adjacent side. 50 is going to be our opposite side, so we'll be using tangent to solve this problem. The tangent of the angle we're looking for, the angle of depression, is equal to the opposite of 50 over our adjacent side of 30. To solve that, we want to take the inverse tangent of both sides. That gets question mark isolated on this side, and then we just have to calculate what's the inverse tangent of 50 over 30. Now 50 over 30 you can reduce to just 5/3, or you can keep it 50 over 30. It's up to you. It's easier for me with just smaller numbers, so I'm going to do inverse tangent of 5/3 to calculate this. And I get approximately rounded to the nearest tenth 59 degrees. That is my angle of depression. So that was kind of a lot of new information. The more important thing was that you learned how to do those inverse tangent, inverse cosine, inverse sine functions. The word problems were just an introduction. We will be doing a little bit more of those kinds of problems in our Kahoot. So set an alarm. I'm very excited. We're doing a live Kahoot next class. Don't forget, I can't wait to see you guys there. Be patient. It might have a few technical difficulties, but I hope it's going to be something fun and different to look forward to. All right. So as always, if you have any questions, you can always go Guardian chat me, or you can shoot me an email. I'm happy to help. If you want to set up a Google Meet, just let me know. And I hope you guys have a great day.